This is also being live streamed on LinkedIn. So let me go live on LinkedIn as well. So now we go live on LinkedIn in a couple of seconds. Okay, now we are live. So
we are live.
Yes. Again, good morning, everyone. Thanks a lot for taking time and joining us in the last of the 5-part series that we have run around Industry 4.0. We started off this series by having a panel discussion with very eminent panelists talking about what is Industry 4.0, why is it important, what are some of the things that we need to consider before we embark on this journey. And then we looked at how how intelligent asset maintenance can actually help us keep our assets working hard for us without over maintaining them, as well as maintaining them on when they need. We also heard about how intelligent products can help us. Just give me a second. How intelligent products can actually help us not only generate new revenue streams, but also save lives even. And then we also spoke about how Industry 4.0 technologies, when embedded in the organization, can actually help improve the safety, security, and productivity of our employees as well. So now we come to the last, but the most exciting part of the series, which is smart factories. How Industry 4.0 can actually enable smart factories, and what that means for our businesses. So for that, we have Satya Sahu, the Senior Director as part of the Innovation Office in SAP in Singapore. He will take us through the first part of the session. So Satya, over to you, sir.
Hey, thank you, Mukesh, for giving us an opportunity and for both SAP and our customers in India. This gives us an opportunity to share what is that SAP is doing in the space of Industry 4.0 to digitize the manufacturing plants. So good morning, and thank you all for joining today's webinar. A warm welcome from my side, and I hope you all are doing well. So I have got a few co-speakers with me, myself Satya Sahu, and I have with me Vipin Gandhi. So he's India Innovation Advisory Lead. And I have with me Marvin, who is the Director of SAP Experience Center in Singapore. So Marvin is joined with Jarel. So somehow we missed to put his picture. That's our bad thing. But however, we have got a team which will make this session not only too much of knowledge, but will make it more fun as well during the course. Okay, let's get started. So we all know that the fourth industrial revolution is fundamentally going to change how the products are designed, manufactured, and delivered. Delivered in the sense not as a product as it is, but delivering the product as a service as well. And most importantly, what we are seeing is how the stakeholders are making informed decision on real time. And in today's world, what is constant is the supply chain disruption. And we have seen the pandemic, the trade wars, and the semiconductor chip shortage, how it has created an imbalance in the supply chain. So under such circumstances, the critical priority for manufacturing companies across the globe is to be more flexible or more agile and increase the productivity with the technologies coming from Industry 4.0. And today's webinar, as Mukesh said, will be focusing on the smart manufacturing, how the smart manufacturing drives the agility or the flexibility, productivity, and sustainability. That is going to be our focus on today's webinar. And we strongly believe in seeing is believing. Okay, so during the presentation, we will showcase a typical Industry 4.0 use case deployment in one of our modern plant setup. So what we have done for today's webinar is, this is the agenda. Okay, since this is a small team, we will be in a workshop mode and sharing the presentation and sharing things live from Experience Center. We'll be asking few questions, very, very simple questions to get your input, and we'll be using the Mentimeter. And as you know, Mentimeter don't register your identity. So feel free to give your feedback and nobody will know where the feedback is coming from. So why we're taking the feedback is this will help us to come up with new topics to share with you in future. Okay, so that's first, like, getting to know each other. And next is we will be doing a whiteboarding to share a industry 4.0 from industry point of view, then followed by a demonstration. And we will be sharing what is SAP's point of view on industry 4.0, and we will share the scope of intelligent manufacturing, that what is that SAP is offering to digitize the manufacturing plant. And we will be having one more session from Vipin. Vipin is going to share what are those top AI, artificial intelligence use cases in manufacturing. And we have been seeing this, the trend of adoption of AI in manufacturing processes. We have been seeing this is growing to a great extent, and would like to share with you and would like to take your feedback as well. And the last is that, how you can begin your industry 4.0 journey. So we have got a format or process. We will be sharing that with you, and where you can get more information. We have got places in the web page, and we have got a dedicated site for Industry 4.now experience. So the one which you see on the right side slide. So we will share that information as well towards the end. So that's in short. So let's get started with getting to know each other. So this is the Mentimeter. So there's two ways you can participate in the Mentimeter. One is if you go to menti.com and enter the code, then you can participate in the Mentimeter. Or one simple way is use your mobile phone's camera and scan this code, and this will take you directly to the Mentimeter. So the first question is, which department you belong to? So let me go to the Mentimeter. Okay, super. Thank you so much. Wow, it's really great. Supply chain planning, logistics, manufacturing. Okay, but we'll spend another, let's say, 10 seconds. Okay, let me go to the next. So in the screen, you can refresh, or automatically it can also come in some mobile phones. So the next is, please share your view on Industry 4.0, because Industry 4.0 has got many interpretations. Okay, most of the interpretation is smart factory, but with the evolution of artificial intelligence, we are seeing the number of initiatives the manufacturing companies are taking with respect to predictive maintenance, quality, digitization of production floor. Could be anything. Would like to hear from you. How you see the Industry 4.0 with respect to what is that you can implement? Smart factory. So let's take 5 more seconds. Lot of potential. Okay. Productivity, innovation. Okay. Excellent. Very, very good input. Thank you so much for sharing. Okay. Excellent. Thank you so much. We'll be sharing this input with all of you, because this gives some ideas to all of us that how its Industry 4.0 is interpreted by different manufacturing companies. Excellent. And definitely, yeah. Process automation is something which adds too much of value to the initiative. Excellent. Let me go to the next slide. So next is, please share any Industry 4.0 pilot or projects you have implemented or planning to implement in your organization. The slide. Okay, excellent. Predictive pilot running. Mm-hmm. Smart factory. Yes, this is MES definitely. Yes, MES and smart factory often goes together with respect to digitizing. But yeah, smart factory extends the definitely the MES and connects with the planning to make it really more and more smart from production point of view. Yeah, absolutely. Great. Okay, good. So let me go to the next slide. Okay. So what are the typical challenges you face, to begin the Industry 4.0 initiative? Like many years ago, it used to be that manufacturers used to say my equipment is really old. Connectivity is the issue, and some says that where can I see the value coming from, because it's not a technical project or technical initiative. It's often driven by the business, that once you see the value only you can budget it. Where to start? Okay, still thinking cost to value. Okay, so we have covered some extent we have covered where you can see the value. We will share the statistics and the document during the course. Budget and ROI integration issues. Okay, good. Okay, thank you so much for sharing. Okay, we'll come back to this later. Okay, good. So thank you for sharing your feedback. Excellent. So with this, let's look at like how Industry 4.0 is transforming the manufacturing industries. And so as a part of this section, what we intend to cover is what are the typical market drivers and dynamics. That's one. And what are the typical challenges the manufacturing companies face to achieve higher productivity. And we'll do a short whiteboarding on Industry 4.0 so that we can get a complete picture of what is Industry 4.0, how industry is pursuing this, and we'll share a few success stories. So that's something we will cover as a part of this section. Okay, so now here it is market drivers and dynamics. So what we know is
Satya, you're still showing the Mentimeter, you not move to the slides.
I'm sorry. I'm sorry. Okay, thanks, Mukesh. Okay, so what we know is the manufacturing environment is changing, and the focus is no longer the capacity alone. Because if it's a continuous manufacturing, capacity makes a lot of sense. If it's not continuous, that if it's a batch or discrete manufacturing, having like manufacturers don't focus only on capacity in today's world. Okay, but on the ability to respond quickly to customer needs and market change while still controlling the cost and the quality. That's the focus what we are seeing from our customer base. And in addition to this, what we are seeing is companies are taking a number of initiatives to optimize the manufacturing processes, to minimize the negative environmental impact, and establishing a safe working condition. This has become a key objective for many manufacturing companies. And in today's environment, supply chain and manufacturing are at the center, not only for the business success, but also for companies' differentiation strategy. And if you look at the right side, the smart factories, this leverage a number of digital technologies to gain a significant improvement in productivity, quality, flexibility, and the way they serve to their customers. Okay, not only by selling the product, but in biscuit manufacturing, we're seeing the companies are offering product as a service, and they share the risk and reward by billing based on the outcome. And some of the key technologies which has been widely adopted by industries are definitely one is the Internet of Things. Edge computing is getting in more and more adoption today and going forward as well. Cloud computing, definitely the innovation can be dropped and can be adopted on the day one when the new feature and functions are released. Not only for software point of view, we are seeing the embedded softwares in the machines as well. And finally, the machine learning we are seeing is taking a lot of momentum and traction in the market. And if you look into the challenges, what customers are facing, that there are key challenges, two key challenges the customers are facing. If you look into this picture, so we have got companies have got a global or headquarter and the plant which is distributed across different geographies, and the system which runs the plant is completely different from the system which runs your planning process or the R&D process. And we see the information is scattered across different systems. So the first key challenge the companies are facing is the silos of information. Information scattered across many disjointed systems. A simple example is production planning system and manufacturing execution systems don't talk to each other, which leads to that, like whatever I am planning, it's not manufactured accordingly. And due to this, the company landed up in either excess inventory or out of stock situation in the market. And second issue, what we see is the manual and inconsistent processes across different processes and different plants as well. That's purely because of the processes are not digitized to a great extent. Even if it's digitized, the different systems running different plants for different needs and things like that. So the silos of information make strategy, operation, and execution completely disjointed. And what we see is the traditional boundaries between the R&D, the manufacturing, logistics, and operations are dissolving within the enterprise and across the supply chain. That's one. And with Industry 4.0, the companies look to break the silos in their processes to gain the visibility and drive the customer centricities to achieve much higher level of efficiency, optimization, and ultimately deliver on new business models. Okay, that's what we are seeing. The challenge is silos of information and many manual and inconsistent repetitive tasks, which is actually not helping the companies to move into that Industry 4.0 journey to improve the agility and to improve the productivity. And let's look at the scope of Industry 4.0 in a simple whiteboarding format. So most manufacturers, they start the Industry 4.0 journey from smart factory initiative, both process and discrete manufacturing industry point of view. There are a lot of key topics the manufacturing companies are taking, such as shop floor automation, like in level 1 and level 2, and the machine data collection, shop floor to top floor integration to ensure that I am producing based on the plan, connecting the MES with ERP and vice versa, both directions. And we are seeing something getting more traction as the predictive quality by combining the machine data and raw material quality data. And now, since last few years, we are seeing is that the health and safety is taking more and more traction, okay, in the areas of energy optimization and health and safety of the people in the plant. So the smart factory is the center of Industry 4.0, and it's just a part of it. To make the factory smart, this has to understand what is the need of the market. So we are talking about the planning. Think about, before we build the product, companies typically decide where to build. In a distributed located plants, companies has to decide where to build and how many to build and when to build. And all this information comes from the demand planning system. And we need to connect this process to our smart factory to ensure the factory manufactures based on the market demand to avoid any kind of excess or low inventory type of situation. And next comes the design. Okay, so the product information comes from the design phase by combining the X and O data. The X data is the experience data, what you get from your customers. The O data is the operational data. So you get it in machines. The machines comes with a number of embedded sensors, and if the R&D team get those sensor data, they will know that what point or what are the scenarios where the product fails or product stop to work, okay, and things like this helps them. This is good input for them to redesign the product in the next phase when they release it. Okay, so to summarize, like the R&D team gets the customer experience data, the product experience data is O data, requirement and spec in a make to order or engineer to order type of scenario, and they kick off a project, design the product, and create the needed master data, that is the bill of material or routing, or the receivable data in the process industry point of view. And that is not the seamlessly handed over to the manufacturing team, which is actually helping the company to product launch in a mass production environment. So far we have seen the smart factory industry 4.0 is not only the smart factory, and the smart factory has to be connected with your sales and planning system and design system to ensure it manufactures as per the need. That's one thing, and helps the companies to actually manufacture new product at scale. This actually helps the companies to make the product launch to a great success. So now next comes, once you manufacture, what's the next? Okay, it's a delivery phase. So after we build the product, we need to ensure on-time delivery of the product to the customer location. And what companies do is they connect with the logistics service provider, optimize the transport plan, and monitor the transportation through blockchain till it receives at the customer place. And this is helping the companies to improve the logistics efficiency and ensure the genuine product reaches to the customer all the time. And now next is the operate. Once the customer receives the product, okay, now companies are thinking, how can we provide a better service through new business model? And many of the topics we see here are building the digital twin of the product or the machines, remote and real-time monitoring of the product and equipments anytime, anywhere. And we are seeing such requirement coming from many manufacturers during the COVID. Okay, and finally, what we are seeing is providing a predictive maintenance through machine learning to improve the operational efficiency of the equipment. Okay, so this is the complete scope. In addition to this, what we see is now companies are looking at how they can interact with their partners on real time. So in today's economy, we see no company can operate in silos. And they need to collaborate with a number of partners in the ecosystem, such as design partners, outsourced manufacturing partners, suppliers, logistics providers, the carriers, transporters. And this with the real-time connectivity, this not only improves the collaboration, but also helps to accelerate the business process as well. Okay. So now why companies do? Let's look at a few KPIs. This helps the companies to secure revenue in the new product launch, time to market. This improves the time to market and time to value related KPIs. And this helps the companies in terms of cost reduction by producing the right product at the right time and optimizing the inventory. Maintenance point of view, by applying the predictive maintenance, this helps to optimize the cost to maintain their own equipment or their customers' equipment. And lastly, the energy. So if you cannot see the higher energy consumption now, then you lose not only a lot of money by paying to the utility companies, but also this actually increase the risk as well as that decrease the total lifetime of the equipment. So there are different ways by applying these technologies companies can reduce the cost, and finally, this also helps the companies to actually come up with a completely new business model to drive a new revenue stream. So the reality here is the business benefits cannot be achieved by any single solution. The only way to do is to have an end-to-end perspective or approach and an integrated solution which helps the companies to optimize the entire business process from end to end. And this is the new scope of Industry 4.0, what we have been seeing when we talk to the customers from a short, mid, and long-term point of view. And there are many companies that achieved it. Okay, I'm sharing few. Ansaldo Energia, the power generation leader in Italy, and they manufacture the turbines, generators, and also they take a turnkey project for power plant construction. And by adopting the predictive aspect in the areas of maintenance, this is helping them to save close to 5 to 8% of the cost in the equipment maintenance. That's one. And CATL, the world's leading producer of lithium-ion batteries. This is used mainly in the electric vehicles, and companies from China. And to meet the growing demand, the company wanted to expand its production capacity while maintaining the stringent safety standard and high product quality. And by digitizing the factory floor, okay, they have increased the production volume by 25%. And they actually, during the course of digitization, they integrated close to 8,000 machines on a single platform using SAP's IoT solution, which is providing a real-time visibility into the manufacturing performance KPIs like OEE, which is helping them to further find out what is the scope of improvement, and this also helps them to continuous improvement activities, which the production planner, production supervisor, or plant manager takes. And this also helps them to get an end-to-end traceability of the processes across the production plants. The last one is the Sleneke Logistics. It's an automotive parts supplier from Germany. And the initiative was, how do smart container speed up the production? Okay, so Sleneke supplies to auto OEMs. The auto OEMs, they can check the current location of the delivery on their tablet, and they also know that now every delivery will arrive punctually at the right production line. So the Sleneke's job is not to take the order and deliver somewhere, but to deliver at the right production line, and in the right sequence, how it is being ordered by their OEM. And this is helping them to prevent delays in the production plants. Okay, and this project was done in 3 months, and more than 1,600 parts been tracked. And with this initiative, this is actually helping their customers, which is the auto OEMs, not only to increase the efficiency, but also zero production stop due to missing parts. There are 3 use cases. And Continental, it's tire industry from Europe. They started with one plan and digitized the production processes, and they created the template. And this template is helping them to roll out to multiple plants. And the left side, you see it's helping them to increase the efficiency. It's tightly integrated to both the worlds, the IT world, which is the ERP, and the OT world, which is the machines and shop floor level 1 to 3 systems. And standardization, standardization and digitalized is helping them to to speed up the rollout across many plants. The value potential, what we see, we did a survey with MPI group in 2020, and I'm highlighting 4, but there are many areas where companies are seeing value. The first is definitely the product quality, and the second is the productivity improvement, profitability across that, optimizing the inventory, then reducing the cost in the maintenance, okay, then energy optimization. And last is that it also helps customer satisfaction, because you produce the right part, right quantity, in the right location. Okay, that's one. And second is you take the feedback directly from your end customer and product in product design process as well. And by using the predictive quality, this ensures the quality is always maintained, not once, twice, but all the time, which ultimately translate to customer satisfaction with this initiatives. Okay. So we see a lot of potential. So with this, let me go to the Experience SAP Industry Forum. So there are 2 sections to it. One is I'll be sharing a short video. Also, video is actually talks about the design to operate. That how can your customer configure the product the moment product is configured, how you can make a smart factory which will understand your customers' customization and produce by integrating your production line with your component, the feeder line, and with the warehouse for seamless and smooth material flow across the feeder line to the manufacturing plant, to the final assembly, and from the inventory to the final assembly for a real-time material movement and the production. So here, what we are going to see is that the product personalization at a scale, how your customer can personalize the product. That's one. The collaborative robot, that is called cobots. Okay, using cobots, how can we create a very unique component based on the customer's requirement, and the visual inspection through cameras using AI and ML. So this is something you will see. Then automated material flow through AGVs, automated guided vehicles, and Kanban. And you will see the IT, OT, and end-to-end integration scenario during the course of this video. And finally, you will see the digital twin. So let me run the video.
How can you establish an open, integrated factory? How can workflows be automated and simplified? As soon as a customer places an order, like a customized and personalized double-seat valve, the intelligently networked process starts. The journey of the intelligent valve begins with component manufacturing. Operators assemble the electronic valve head according to user-specific requirements. They are supported by an integrated cobot that hands over the order-specific components. An attached camera uses image processing and machine learning to ensure consistent quality. This also helps to avoid errors. All data is then verified, and operators can provide feedback on the order at hand. The component is managed with an electronic Kanban flow application. The material box is supplied to the next work step on request. The main assembly process starts with a prefabrication of the identification plate. To personalize the double-seat valve, the individual plate is printed according to customer configurations. Here you can experience Industry 4.0 orchestration scenarios. The pre-assembled valve head is then brought together with a finished identification plate to continue its journey on the extended planar system. First, the kit is lifted on a free-floating planar mover with a cobot. Here it moves smoothly and contact-free over planar tiles utilizing electromagnetic forces. The kit stops at the visual inspection station and is photographed and verified by means of optical quality inspection, empowered by machine learning. Then the cobot lifts the kit to the scale to check the weight. All production data is collected and documented. If any value is out of tolerance, the kit is transferred to rework before continuing its journey. If all key figures conform with the target, it circles until it is picked up by an AGV. Through vertical and above all horizontal integration, all areas of manufacturing communicate with each other. All processes are seamlessly integrated and can be monitored using SAP solutions for digital manufacturing and SAP Extended Warehouse Management. This way, all materials and components are available at the planned location in time. For final assembly, all materials are automatically staged to the workstations with the SAP EWM using the built-in material flow system to control the automated warehouse and a direct communication to control the AGVs to pick up all materials. There, the kit arrives at the same time as the corresponding raw valve. The AGV system constantly evaluates the overall situation and possible routes. So the vehicles automatically head for a free assembly station to supply all the necessary raw materials. Here, operators are supported by an intuitive camera guidance and interface. They receive immediate visual signals. This way, they always know whether all relevant production steps were carried out correctly to ensure high quality and avoid errors. The finished valve is then automatically picked up and transported to functional testing. Here, the operator initiates the test process via gesture control. Compressed air is passed through the double seat valve to see if it works correctly. All test results are recorded to ensure full traceability. The finished checked valve is then stored and ready for shipping. As the valve is completed, the digital twin is created as well. Together with all relevant production data, it is the single source of truth for further processing and operation of the double seat valve. This way, the open integrated factory supports its operators and forms the basis for a continuous improvement process and frictionless digital supply chain.
Good. So what you saw here are all integrated with SAP's digital manufacturing software. That is one. And you see a number of machines, number of robots, and number of equipments, quality check, and things like that. So this is all connected with SAP through a component called plant connectivity, which is nothing but a OPC client, and this actually helps us to get the data and send the data in both directions, to achieve a real-time digital and intelligent manufacturing. That's one. And the second is a lot of data get exchanged between ERP and to the various processes within the plant. Okay, so yes. So with this, let me hand it over to Marvin and Jarrell to show live some of the Industry 4.0 scenarios from Singapore Experience Center. So over to you, Marvin.
Thank you very much, Sahu. Hi, everybody. Very nice to be here with you today and share with you a few of the, I would say, use cases we have in the center in Singapore. But, COVID obliged, we've been very smart into transferring those different use cases into a virtual world. What you're about to see, and Jarrell and my team will be showcasing, is a few examples about how technology can be leveraged in an intelligent factory scenario in order to help you get the right, I would say, benefits for your operation, or get you the right, or fix the right business challenge. So at the Experience Center, we've been really focusing on this, right? It's not really about the solution. It is a little bit about the tech, but it's really about what do you want to achieve? Is this really about maintaining or optimizing the connection between the resources, people, and machine together? Is it about reducing the day sales outstanding into your inventory and using robotic for this? Is it about bringing safety to your worker as they are, reducing the time to learning thanks to augmented reality? So all of those topics that we see a lot nowadays with our customer, we show them in the Experience Center, but we also show how this can be integrated into your existing application and which ecosystem we've been working on and tried on a few of those use cases to help you deliver those innovation in a faster time. So that's really what the Experience Center is all about. So we've curated for you a few demos. Jarrell is going to take us through that. Please ask your question in the chat. We will be sharing a brief summary write-up of all of those different use cases with which customer of ours are currently using it, so we can do follow-up with you. Very excited to do the showcase. Jarrell, over to you.
Thanks, Marvin. So hi, everybody. My name is Jarrell. I'll be hosting you guys at the Experience Center today. So I just want to say, hello to everybody. We'll be showing you 4 different demos across a few different perspectives. So, stay with me. I think it'll be very interesting. So in the interest of time, I'm going to get started. So I'm going to go straight into the highest level we can possibly see. Smart manufacturing. So I'm going to show you smart manufacturing, which is a bit like a mini production shop floor that you guys are seeing behind me. Are you guys able to see this?
Yes, Jarrell, we can see it.
So what you're actually seeing is actually a little product.
Can you just position the camera a little more down so that we can see the entire thing? No.
Yeah. All right.
Just a little further away. Little more further away. Yes, now we can see the entire thing.
Okay, great. So what you're actually seeing is actually a mini production floor. And what this has actually is a few different sensors across the entire production floor. And you can imagine this to be a factory for motorbikes. You can imagine it to be a factory for whatever it is that your company does. But the main point here is that it leverages IoT sensors, in this case RFID, at different stages within a production life cycle in order to gain information about every single stage. So I'm going to turn that off really quickly and show you a bit of the dashboard as well. So all this data that you see in the different shop floor, you can actually see on a unified dashboard where you can actually see the production rate, the total units that have been produced in lifetime, and also the individual ID. So I'm going to bring myself back up here and explain a little bit more about what this is. So you can actually get data from the sensors about every single stage that happens within that production life cycle. So the main business value here is that this data then empowers you to optimize business operations. But more importantly, it also protects you and your consumer. So using data from IoT sensors that leverage technologies like RFID in this case, each individual product or package is tagged with a unique identity that is registered at every stage. You cannot go through, for example, point A without going through point B, because we will be able to see that. So what this means is that it stops you, with such great clarity, what is happening is with each individual on the shop floor, with such unparalleled levels of specificity, this would protect you and your consumers from, say, counterfeits, which would otherwise not fit into this ecosystem at all. So it would immediately be flagged. So I'm going to bring you over here to the dashboard just one more time, and you can actually see, for example, are you guys able to see the dashboard?
Yeah.
Yeah, so what you'd be able to see is actually over here, you'd see the individual IDs of all these different things. So here, the point is that you can actually see the life and the live position of every single product. So this means that if you put a counterfeit into that system, you would get noted immediately. And so what I have here in front of me is actually this little ball here, which would play the part of a counterfeit. So I'm going to position you back down over here, and what you'll see on the screen when I actually put this little ball down through an RFID scanner, it would actually get alerted of that error itself. So that's one of the ways that you can actually see this. So on top of preventing counterfeits as well, this data will also allow for users to use this data for greater analysis to optimize your operations. So for example, you can leverage AI to study this data to quickly identify bottlenecks in operations and even suggest solutions to optimize these processes as well. So a great use case here, for example, is Harley-Davidson, which actually leveraged this technology to turn a 4-week production process into a 6-hour process. So this is just one of those sort of very high-level areas where you can use this data to look at what's happening on the shop floor in real time and analyze that data so that you can identify areas where there are bottlenecks happening, or whether the quality control in certain areas are not being done very well. And then you can change business operations in order to optimize that. So this is a very high level introduction into how this might work. I'm going to take maybe a quick minute here to leave some space for maybe Marvin or anyone from the team if you have anything to add on here.
Thanks, Jaron. I think maybe just something to really highlight is those type of, I would say right now we're looking at is sensors and traceability, right? The idea is that you can, identify potential bottlenecks, and if there is any quality issues. So this demo that obviously you could see a bit better if you guys would be coming to Singapore, but it really helps with product recall management. It helps as well if we use RFID here, but it could be any video analytics that look at for example, the way the product look like, or the way the product, what is the weight or the color. And you can use that information during your production line to actually help you identify potential quality issues, go back to your supplier, go back to your maintenance operator, and fix those before final assembly, right? So it's really about, when we talk about automation, is how do you leverage, things like IoT, machine learning, predictive analytics to help you figure out, the perfect operation landscape. Over to you, Jao.
Thanks, Marvin, for that. So we have kind of covered the manufacturing side of things, but over here at SAP, we want to look at the entire end-to-end process. So beyond manufacturing, we also want to look into how we can ensure all other supporting functions can be optimized as well, which is why I'm introducing to you behind our smart warehouse. So this solution actually leverages the use of drones in order to gather and analyze data across machines and business systems in order to enable faster, more flexible, and more efficient processes in order to produce high quality individualized goods at even lower costs. So what is this process itself? what this process is a drone would actually fly to a shelf, which is a pre-planned route, and it takes a picture to store in the back end of the system, which is then after which it would take that image and then send it back and return to where it actually took off. So by scanning the inventory, what's actually doing is counting the number of packages, and then this information is sent to a database where the numbers are actually being cross-checked. So this method is actually significantly quicker than manual staff checks as well. Moreover, it's even safer. Imagine if your space is very large, your staff would have to walk a very long distance just to check something. And even worse, if it's very high, they would have to climb. That introduces slower processes and even more dangerous processes. So in a short while, what we're going to see is actually the drone take off in a very short while. But for that moment, I want to just maybe talk a little bit more about why this is such a great thing, right? This information can later also be fed into inventory management systems, and this data would empower you to be able to run greater analysis and leverage analytics to study historical data on consumption and even predict the runway for current stock. And this also builds the foundation for automated procurement in the future as well. So what we're going to see in a short while is the drone is flying. Are you guys able to see it? Let me bring it closer.
Yes, we can see it here.
Yeah, so it's gonna fly, it's gonna fly in a path.
You can put your camera a bit lower, so and maybe I can explain if you allow me to step in here, Jared, right?
Yeah, please do.
So obviously in the center, what we've done is we've programmed the drone to be connected to your warehouse management system. Because the whole idea is to make sure that not only you understand what is in your physical inventory versus what is in your system, but also what the drone can do is analyze, with machine learning recognition, for example, how your different warehouse, boxes are, right? Which state? Is there going to be any water stain? Is there any damages on the boxes? But eventually you want to make sure you understand if there's any shrinkage that should not be here. For example, if products are missing that have not been sold into your system, you'll be able to be made aware of that, and just automatically program the drone to do those kind of checks into the different spaces. Could be drone, it could be a TV that you implement as well into the different system. It really doesn't matter how which hardware you use, as long as you really connect what you've been selling into inventory with what you have reality into the stocks. And what you're seeing here, that photo, maybe Jared, I'll let you continue.
Yeah, so what we're seeing here is actually what is recognized in that box alone. Then this data is being updated live into the database as well. Sorry, Marvin, I interrupted you. You were feel free to continue adding.
Excellent. So basically the whole idea is to, once you have that information, so now the drone will be calculating, yes, we have 18 of those products, right? You can also combine this on the shelf with a weighing sensor that will be able to tell you exactly how many products are left, because sometimes, it's not only about one box, but, some of those delivery could be component within that box or within that pallet. So you can go as complex as, 2-3 layers of AI integrated into your system to make sure you can automate what's being sold versus what you have in the system, and how do you send the information to the warehouse worker.
Great. So again, as Marvin mentioned earlier, if you guys have any questions, please do send them inside the chat itself. And maybe later on we can choose a few to address, especially those common questions that we have. But that is what we have for smart warehousing. And I want to bring you to our next demo. But before, what it is basically we've spoken a lot about optimizing business operations using data from IoT sensors to make your businesses better and the experiences for the consumers more enjoyable. But let's talk a little bit about the experience for your staff on the ground. How can we leverage all this information to ensure safety? How do we use this information to ensure efficiency? So I'm going to bring you guys over to our next demo, which is actually called Asset Manager. And as you can see, I'm walking through, give me a few seconds to walk through the center just really quickly. And I bring you to our next demo here, which is Asset Manager. So what we have as an Asset Manager is actually a unified platform that compiles data across different IoT sensors in a factory floor in order to ensure two things: safety and efficiency. So let me pull up the screen really quick. I'm going to share my screen. And what we're going to do is we're going to take the perspective of a field technician now. Previously, we looked at it from a very high level view of what what a manager would do, what someone who's running a factory would look like. But what does it look like for the staff on the ground? What this does is, are you guys able to see the iPad?
Oh, yes, yes.
Yes.
Okay, so what you guys will be able to see is the iPad, right? And what we're going to do is I'm going to show you the asset manager demo that we have. Today, we're taking the perspective of David, the field technician. And so, like I mentioned earlier, this data is being fed into a platform like this. And what you're going to be able to see is a wealth of different streams of information coming from different IoT sensors on the ground itself. So first and foremost, you'll be able to see, for example, all those in red, the work orders in red, which are more urgent, work orders, and you'll be able to see, for example, certain safety precautions like the orange marker over there. So I'm going to talk about how these data empowers field technicians to work efficiently. So the first thing I'm going to do is take you over to our piece of technology here. This is our factory equipment. You can think of this in any context, right? It could be any form of equipment, but in this case, this is what it is. And so what is going to happen is it's going to start working, and you'll see that the light is green here. And as we slowly turn it, it goes red, and this means that there's a low pressure in the asset. So I'm going to stop it really quick and bring it back up to my face to explain. So the information from there, the fact that, for example, there's low pressure comes from IoT sensors within this particular piece of equipment itself. So what a field technician can do is use this information for him to be able to gain greater visibility into what's going on within this piece of equipment, and then run diagnostics, and later on, of course, proceed to fixing the equipment itself. So I'm going to click on the actual work order itself, and you're going to be able to see on the platform, you can see that there's low pressure. And this, of course, is coming from an IoT sensor. You'll get suggestions, you'll get operations, a pre-service checklist, equipment, error codes, and of course, comments. And I particularly like this comment section the most, because in this day and age where people are changing jobs here and there, and the turnover rates in certain areas are higher than others, this comment section will be able to give you a brief history into this particular piece of equipment. So even if there's a new technician on the ground, for example, he would be able to see that. But beyond this, how else can the IoT sensors themselves, data from that, ensure efficiency in the diagnostics of the problem? So I'm going to actually analyze the source drop here. Source of the drop here, and you actually see on the screen the iPad. It's a real iPad, it's a real screen. I didn't rig it, it's not a video. So it's actually created a digital twin of this piece of equipment itself. And from there, what you're going to be able to see is information being fed from inside inside this particular piece of equipment itself to the data here. So of course, this is not a live piece of equipment, but if it were, you'd be able to see the inflow rate, the outflow rate, the temperature of this equipment, the distance, the RPM. And this is not limited to those specific categories. It's just in this case, that's what the IoT sensors are built to be able to do. But imagine in any context of yours, depending on what kind of data you're trying to capture, you can of course use different IoT sensors in order to do that. So let's start with the first basics. David wants to fix this particular piece of equipment. So the first thing he might do, for example, is through sound. So he might, for example, use the AI that's trained to recognize certain frequencies of when the equipment is working and when it's not, in order for it to recognize certain aspects of this particular piece of equipment. Sorry. So, for example, if an AI is trained to recognize that a particular sound, a particular clinking sound, then it would be able to diagnose that of that particular problem. The next thing that it could do is through temperature. So through sensors that measure temperature within the equipment, you could actually create a heat map for the field technician to be able to visualize this and maybe see, for example, in this corner here, it's particularly red. This might mean, for example, it's very hot there. That might be excessive friction due to something being loose or two pieces being too tight together along that area as well. And of course, next, something that's really cool as well is through the components. Say those two things don't really work. How else can we use this information to digitally disassemble? So you can further that diagnostic process by digitally disassembling this piece, and you'll be able to see here, for example, each individual piece here. So this is particularly useful for complex pieces of machinery where technicians, for example, would not be able to memorize every single thing, and you'll be able to see within each piece what the problem probability of it being the problem might be. In this case, you'll be able to see the component issue predictions. So by looking at historical data on consumption and of course data that's been logged by field technicians, you'd be able to see that most likely the problem is the O-ring pressure seal. So this is one of those ways that we're able to leverage the IoT sensors data from IoT sensors in order to make sure that workers are able to work as efficiently as possible and make that experience a lot more seamless and less technical in nature. So I've covered a lot on the efficiency part, but I haven't spoken enough on safety. Earlier, I mentioned that IoT sensors also help us to ensure safety beyond just efficiency. So what you're actually able to see here, the first point I made, and I briefly mentioned this earlier, is the orange demarcated area here. You'll see headphones over there on the iPad itself. And what this is actually meant to describe is an area in which is very loud. And this is information coming from an IoT sensor placed inside the room itself. And so think someone might be,
we need to maybe mute someone. Sorry, is it possible, Mukesh or Sahu? Oh no, I think it's good now. Perfect.
all right, great. So this is actually information coming from IoT sensor within that room itself, not someone actually going there to listen. But this isn't all. This isn't the extent to how impressive this can actually get. We can actually use IoT sensors to measure the actual physical state of our staff itself. So what you're seeing here, I'm going to show you on the camera, is this here. Are you guys able to see this helmet over on the camera?
Oh, yes. Yes.
So in this helmet, you see the very light blue light. You can actually see on the light blue light itself, you can actually see that it's actually an IoT sensor embedded within the helmet. So we go over to the asset manager here, we check for the worker safety. We can actually look at information coming from this sensor. For example, the temperature of the head. Of course, I'm not wearing it right now, which is why it's 26 degrees. But you can also measure things like the ambient sound, the heart rate. And of course, just to prove that I didn't rig this, I'm going to artificially increase the temperature over here of the helmet itself. And you'll be able to see the temperature actually rising. You guys able to see that? Yeah, 30 degrees. And it can even get to fairly dangerous level if it goes up and more. So this is one of those ways that we're able to make sure that workers in particularly warm environments don't suffer from things like heat stroke or they faint. So we make sure that. And lastly, of course, one of the most common issues, knocking, right? If someone takes a fall, you would get a notification. So that is one of those ways that we'll be able to leverage this technology in order for us, sorry, give me a second, in order for us to be able to ensure worker safety on the factory floors and even more importantly, also just as importantly, efficiency. So we're able to make sure that work is being done very fast, but not at the expense of the safety of your workers. So I'm gonna stop here for a quick second to see if if there's anything you would like to add. Anyone on the team or Marvin, anything to add on this front? Otherwise, I will move on to the next part of our demo. So I mentioned here how we leverage technology in IoT technology in order to make sure that diagnostics is done. But now I mentioned also the importance of making sure that the experience of each field technician is comfortable, is seamless, and of course is efficient. So what I'm going to show you next is the follow-up. So let's say in this case, I've already diagnosed that this particular piece of gear is the problem with the equipment. So behind me, what I'm going to be showing you is actually an app here. So what I'm going to be showing you in my next demo is actually called Ariba. And Ariba is a demo that combines, it's a chatbot that combines Ariba and chatbot together. And this is to help the procurement process of each field technician much more seamless and less administrative in nature. So how is it that we're actually able to do this? Behind me, you're actually seeing the app. So after a field technician has diagnosed the problem, for example, with that piece of equipment earlier, he's decided that this piece of equipment is the issue. So what I'm going to do is I'm going to place it down here very quickly. And what I'm going to do is try to procure this through the app itself. So behind immediately, I'm shown the interface. It was asking me what item I would like to purchase. And of course, I want to purchase this piece of equipment. So what I'm going to do, as you can see, it's live. It's a real video feed of me. And I'm going to take a picture of this equipment. And what's going to happen...
Can I ask you, could you lower the camera a little bit, please, Charles, so we can see the back? Yeah.
move it further.
And then or lower. Yeah, or you just, yeah, perfect. Yeah, thank you.
Right. So what you're going to be able to see is that I've taken a picture of this equipment, and what's going to happen is an AI that's trained to recognize these pieces of equipment will start to recognize this. And it looks a little bit blurred on my end, but what it's showing here is that it's recognized this piece of equipment and it's shown an 89% match. So from there, what I can do is I can actually order this piece of equipment now. And from there, what would happen is that it would immediately ask the follow-up questions, the kind of questions you would get in a form that can be very slow and very annoying. But when you take it step-by-step process, it's a lot more seamless and more comfortable. So for example, this is asking how many pieces I would like. Let's say I want 3. And it's an expensive piece of equipment, so it requires a certain layer of approval. And so it's prompting me to send an approval request from my manager. And I click yes here. And the requisition would have been sent over, the requisition request would have been sent over to my manager, who will then be able to approve and create that process. So this would mean that field technicians no longer have to fill out very technical names or have to be very specific with what they need, because they are able to take pictures and the AI would do all that heavy lifting for them. And this would also, of course, take off administrative work off the main office as well. So this is one of those ways that we're able to have that end-to-end experience from the diagnosis to the procurement and later to the fixing as well. So that is actually the last demo I had shown for today. So yeah, so just to summarize, today we've shown you our smart manufacturing, our smart warehousing. Those are demos that leverage IoT sensors to show us how we can really make sure, from a very high perspective, we can optimize business operations. We can make sure things are faster, smoother, and of course, safer. And with the Asset Manager and a Rebot, we show that this technology isn't just limited to making sure that the consumers and the managers' perspectives the experience is well and smooth and comfortable, but we can also make sure that from the field technician's perspective, for the people on the ground, this technology can be leveraged to make sure that they're safe and of course, just as efficient, and if not even more efficient. Yeah, so that concludes my presentation for today. Are there any, is there any time maybe for us to address some questions, or Marvin, anything to add?
Gerald, we'll take the questions towards the end. Thank you so much. Thank you, Marvin. Thank you, Gerald. Thank you for sharing and streaming the scenarios from Experience Center. Thank you so much. So, anything, Marvin, you want to add?
No, I said no. Thank you very much. You're welcome. And yes, any follow-up, I've already answered to a few of you in the chat around what we do for process industry, where, I obviously send you some link, but what you've seen today, guys, just obviously just a snapshot of what we could be doing. We go much more higher into the personalization detail as needed, and we'd be more than happy to take you through a personalized Industry 4.0 tour. If you reach out to us, we would organize that. So thank you very much.
Yes, that's a good point, Marvin, what you brought. Like in case we want to have like a dedicated session for you and your team, please reach out to us, and we will be more than happy to host you.
Thanks, everyone.
Yes. So so let me take it from here. So so we have got a website called Industry 4.now Experience. So this is the link which we will be sharing as a part of the deck. So if you go here, you will find a lot of details about some of the statistics, some of the survey as a part of Industry 4.0 and now. And discrete and process industry, we know that the Industry 4.0, the way it's implemented, varies from industry to industry. So hence what we have done is we have actually designed the scenario for per industry, and that is something covered in this 2 links what is shown here. So the moment you go into the details, this actually takes you through that how SAP can help in making your design more smart, making your plant more smart, and manufacturing, so on and so forth. Okay, so this is a good web page where you'll get more information about SAP's offering in the areas of Industry 4.0. So with this, let me go back to the slide. Oops, sorry. Okay. So next is SAP's point of view on Industry 4.0. So SAP's point of view for Industry 4.0 is to move the digitization from factory focused initiative to a company-wide. And you have seen when I was doing the whiteboarding, it's not only the factory-focused initiative. To make the factory smart, it has to be well connected in the entire value chain. So that's why SAP's point of view is to move the digitization and Industry 4.0 from factory-focused initiative to a company-wide and competition-beating business strategy. Combine the manufacturing automation with the enterprise business processes. This has to be combined to achieve this objective. And this has got three key focus areas. One is the center and the customer. So their input and preferences are the source of all you do. That's one. The moment you think from customer's point of view, you will see that your customer's requirement is very unique, and how you can make the manufacturing more and more smart so that it can produce the customization at a scale. And to produce the customization at a scale, which you say reinvent the production. So the plant has to be connected with your entire company, from sales, service, and logistics with production to transform how you work. And to achieve this, what we have done is we came up with 4 themes. And themes are intelligent product. This actually helps the companies to accelerate your product design by getting the accurate customer experience data and product experience data from the embedded sensors. It also do take care of seamlessly handing it over to the manufacturing team to speed up the mass production of the new product. And this actually helps the companies to improve the KPIs around new product and introduction to the market. So that's one. And second is the intelligent factory. This helps the companies on their journey of smart factory and ensures the right product is manufactured at the right time with the right quantity, and provides a platform to manufacture highly customized product at scale using your existing production line. You don't change anything. Only thing what you need to do is that digitization in the assembly line. And this also supports the cellular manufacturing, which we have been seeing in some industry. It's been adapted to further optimize the capacity. And by digitizing, as we know, this helps the companies to improve the KPIs around OEE, overall equipment effectiveness, productivity, quality, and and energy consumption and emission reduction, and many advantages what you will get with intelligent factory initiatives. Third one is the asset. If you see so far the data generated by the asset or the equipments through the plant automation systems has been used in silos, and then combining the OT data and IT data, achieving a predictive maintenance. So now only we are seeing that's possible at scale, I would say, because there are some few POCs in the past, but now we are seeing many companies are actually best leveraging this IT and OT data to accurately predict the maintenance. And last is the empowering your people. And no matter how much automation you do in the factory floor, people take action. Okay, and they need to have all the information to take the informed action and decision by getting the data, and it should be prescriptive finally, so that they can take the decision quickly. Okay, so that's one. And last one is the business network. As we see that no company runs in silos. So companies collaborate with the partners across design, manufacturing, asset maintenance, and logistics and operations as well. So we provide a cloud platform or the solution using which companies can better collaborate or collaborate in real time for any need across all the value, across all the departments. Okay, so this is the 4 pillars and business network across all this four pillars. So that's 4 themes from Industry 4.0 from SAP. And today we are focusing on intelligent factory. The others covered in the past webinars. And from intelligent factory point of view, we have these solutions. One is the digital manufacturing cloud solution. This is a public cloud offering from SAP. This helps the companies to get the insight, how the plant is or the production is running, and helps to digitize the factory. Okay, that is with the manufacturing execution. This is nothing but a MES on the cloud, and also helps the companies in solving the quality issues. So digital manufacturing cloud is the public cloud, and manufacturing suite is the private cloud version of SAP. And in addition to this, we have got a number of capability within S/4HANA manufacturing, which actually is a great foundation for many companies to start their Industry 4.0 journey. So this supports the production planning, and this supports the planning and scheduling, which is actually the constraint-based planning basis on which you can maximize the capacity utilization. And we have got a new product called production engineering and operation. This is targeted to complex manufacturing type of scenario like aerospace, defense, marine, and a few more where the design keeps changing during the production. And it has got quality management, planning, and of quality planning, quality recording, and a few more things, 8D quality. And last is that environmental health and safety. This covers the three aspects, like people's health, that is one; product compliance, that's the second; and third is the environmental compliance, which is part of EHS, which is embedded into the S/4HANA manufacturing. So this is the complete suite of products to digitize and to ensure your manufacturing is not only intelligent but highly flexible, which is the need of the hours in today's environment. And this is a blueprint architecture. Intelligent manufacturing resides here, which actually connects with both shop floor automation and enterprise to make the manufacturing floor more and more intelligent. And lastly, that from sustainability point of view, across design to operate value chain, we have got solutions. For example, design products that are recyclable and environmentally sustainable, plan to reduce the emission and ethically source the material. These are the capabilities available in our IVP solution. And manufacturing solutions helps you to minimize the waste and environmental impact. And solutions for delivery, that is transportation and the warehouse. Okay, this helps with logistics processes that optimize loads to reduce the mileage and carbon footprint. And finally, the operate assets and equipments in an energy efficient manner that is safe for environment and in the workforce. And lastly, you can leverage the network, which is the business network, to collaborate your partners to support a circular economy and overall sustainability business models. So you see the solutions helps across design to operate cycle, and we have got solutions which will help you in your sustainability journey. So with that, let me take one more feedback from your side. So let's spend 10 seconds. So you saw 4 themes: intelligent product purely from design, factory from making the factory more agile, more smart and digitized, and intelligent asset empowering people. So want to know which themes are the most relevant for your company's Industry 4.0 initiative. Okay, so factory often comes as one of the key initiatives. So let's hear from others. Okay, we see asset also is one of the key initiatives because it's a capex investment, and AI and ML can do a lot in improving the asset life cycle. Empowering people, definitely one of the key, because there's a lot of data which is generated in the system, which can be best leveraged by deriving what is that people should do on that data. And if you could automate the workflows, that adds more value. Okay, good. Thank you so much for sharing your feedback. So with this, in the interest of time, let me hand it over to Vipin to take us through on the top as AI use cases in the manufacturing from India. Vipin, over to you.
Thanks, Sahu, and good afternoon, everyone. Can you please bring up the slide, Sahu? So while Sahu brings up the slide, what we are going to be doing is take a step back a little bit and find out why we need predictive maintenance. What are those things that we can do on the shop floor? What are the things that we have done on the shop floor and got some ROI out of it? And ultimately also discuss where do we start and where do we end? What is it that is going to give me the right path to implementing all of these pieces? So what happens if I start halfway through or wherever I feel like starting, and what are the consequences or repercussions of doing that? So we'll be discussing all of that piece, right? So if you see here, there is a graph that has been put in, and we'll be talking about the predictive maintenance piece first, and then we'll talk about the other pieces that we can bring into play as far as the hardcore shop floor activities are concerned. So if you see here, there is a, let's say, an audible noise starts coming in, and you then, between the noise starting to come in and the failure, there is very little time left, and therefore by the time you react, the part has already broken down, and therefore your machine is at a standstill, and you are losing time and production out of it. But this is the human driven approach, which has been there for quite a long time. These days it is it is reduced to a minimal, because not many people now still are working on human driven approach to maintenance. So now what the next step was that, then we get into the equipment driven initiative, which means that we will try and figure out, yeah, there is a noise coming in, do some vibration analysis, figure out if it is hot to touch, figure out if the RPM, etc., has sort of increased, reduced, whatever, and then find out that there is something that is wrong. In an earlier video, we saw how that noise can tell us whether there is or vibration can tell us whether there is a possibility of a failure or not. Now, this is giving us a little bit more time for us to react and ensure that we don't get into a breakdown situation. We can probably shut down the machine, repair it, and then restart again, but we don't get into a breakdown piece. Normally in a breakdown, because it is a surprise stoppage of the machine, it takes a longer time and duration to get back into the production mode, and therefore this is a mode where we should be avoiding. Now let us look at data science coming into play here. And again, you have seen a lot of examples earlier in this webinar and the series that we have been talking about. If I bring in data science technology here, engineering models plus machine learning or artificial intelligence coming into play, then I get a substantial amount of time, because I'm now getting a prediction to say this product or this material or this equipment or a part of this equipment is going to fail in, say, 24 hours time or 48 hours time, whatever, or it will start giving you indications that something is not working right and therefore it might fail, which means that again you have enough time to plan for that shutdown, take a normal shutdown, correct it, and then restart, which means you have saved some amount of productive time here, and you are in a position to not just repair based on these things. You move from your preventive maintenance to a condition based monitoring and maintenance piece, which in itself reduces the cost of maintenance on a regular basis. And there are multiple advantages of moving from preventive maintenance to the condition based maintenance piece. So how can we go next, please? Thank you. So what are we trying to do here? We are trying to say that there are twins, digital twins that we will create, which you saw in detail earlier in this session. And then on top of that, we will put in some machine learning models, and therefore we should be able to detect an anomaly. Anomaly means that something is not right, and therefore you will see a peak somewhere in the graphs that you're seeing on the screen, which means that it is time for you to act and ensure that things are under control and there is nothing that can go wrong. It will give you probability of failure, which means that the system will tell you that there is a 60% likelihood or there is a 20% likelihood of this equipment failing or this component failing. But once it has failed, or whenever it fails, there will be an analysis of why it failed. What was the root cause? What was the action taken? The kappa piece of it, right? And therefore, you have and my colleague also showed this to you, you have a very, very clear picture of why certain things failed. And next time when you encounter a similar conditions, you're in a position to know that this is going to fail. These are the part replacement that I need to do, or this is the action that I need to take on. You also get the remaining useful life analysis done here. What does that mean? So I'll take an example of a bearing. If the bearing has, let's say, by the OEM says that there are 50 lakh cycles is the life cycle of this bearing. But if you have been maintaining this bearing very, very nicely, and you have been adhering to these condition-based monitoring alerts, you can possibly extend this life to, let's say, 60 lakh cycles. Now, in a normal course, you would have removed that bearing at 50 lakh cycles and replaced it with a new one. But here, because of the ML and because of the insight that you have, you might as well increase that life by 15-20%, which is again savings of money, and you are extracting the full value out of the whole thing, that is the equipment that you are putting in place. So can you go next, please? So let us talk about some of the use cases that we have deployed, some of the things that can actually give you the ROI. Now, how is this ROI calculated? So normally, and there are formats available, we can share those with you. We can, collaborate with you on this ROI part. But here, what we did in this specific case was that we found out what is the opportunity cost. How much time would I have lost if it had failed, and we had not predicted that it's failure. And then what is the kind of production I would have lost in terms of the time that the machine was down, and during that time, how much production I could possibly have done. So here, what we are looking at is, and in this case, it was the testing machines that we were trying to maintain. So we started predicting when the machine is going to fail, and we started predicting it at least 24 hours in advance. And the probability of failure also was, notified on a screen, which was available for, which was visible for anybody who's operating on that particular machine or that particular line. Now, what happened was that because of these probabilities of failure, because of these early indicators, because of these anomaly detection pieces, they were able to convert most of their breakdowns into normal shutdowns, which means that they were ultimately able to reduce the time taken to either repair or replace a certain equipment or part. Their estimation was, if this goes, and this was a pilot that we had done with Mahindra Heavy Engines Limited. If their estimation was per year, they will be saving about $2 million if they were able to, put this, expand this across their engine manufacturing line. Additional savings because of low warranty costs, because now the product quality also is now good. Their estimate was upwards of $1 million they will save from the warranty cost, and about 350 labor days were saved, which in itself has a certain cost that you can easily calculate based on the salaries, etc. Right? So clearly, this is where the ROI comes in, and we need to, at the start of the project, we need to fix up to say, this is where we are starting. When we are starting, this is the situation that we have, and when we end up, we should do another round of analysis to find out how things have changed, and then project them into the future to see how or when we are going to break even or start earning from the technology that we have put in. So can we go next, please? Now, OEE, or overall equipment efficiency, we are all used to this thing. Some of us are monitoring this religiously. Some of us are planning to get into this thing. This gives us the overall efficiency of the plant or the line that we are running. Now, this is a very, very good indicator of whether we are on the right track, or are we missing something, or are we doing something which can still be improved. But it is a lag indicator, meaning that it is a post facto analysis of what has already happened. Now, on top of this, when I put in an algorithm of artificial intelligence, I can possibly look at predicting when my OEE is going to dip, and therefore start correcting those things so that my OEE actually doesn't dip, and I am still at a steady space a steady pace, I am doing the manufacturing, and the OE remains at an even keel. Some of the things that can possibly happen using the digital manufacturing cloud and IoT and SAP AI foundation is that you can understand that the production of scrap is increasing, and therefore the quality is going down, and therefore there is something that needs to be done before you consume the entire piece of material and then say this is rejected because of quality, or you need to rework or replace those things. So you've not just saved money, you have also increased the efficiency of the production, and you have improved the quality of the output that is coming out. Sahu, next, please.
We have 4 minutes, Vipin.
Yeah. Now, this is one very important piece that I believe should be used by most of the manufacturing organization. This is about artificial intelligence being used in order to find out what is wrong with the part, right? So there are two things that are happening now. One, artificial intelligence is picking up the sensor data and analyzing and telling you what might be wrong or what might fail or what might go wrong. Here, there is a visual indicator that has come in. So you visually inspect, take a picture, and the artificial intelligence algorithm will tell you what is wrong with this. On the right hand side of this slide, you will see that there are predictions that have been done that the probability of a certain thing not working properly is 97%, and therefore you can now log a ticket directly from the system and get somebody from the maintenance team to take a look at it and correct the situation. And that is where you are again improving the uptime and reducing the breakdowns that are happening. Sahu, next, please. And similar thing can be done in inspection. So while, like preventive maintenance, there are prescribed times when you need to take this inspection. But with the AI, we can figure out when, at what pace, or at what time duration, or what component duration that we need to, sort of start inspecting. Again, it brings in efficiency, and it tightens the quality of the product, and therefore, again, improves the uptime, improves the production and throughput, etc. Sahu, next, please. Now, identify the root cause at 8D. Now, from any organization perspective, although this is an automotive manufacturing use case, but from any perspective, if you look at how to find out what went wrong, root cause, and then therefore the kappa, it is imperative that we understand what these root causes titles are or categories are. So this application will help you identify the right root cause, and therefore log in the right details, log in the right defects, log in the right solution to it, and therefore, next time it happens, you are already aware of what needs to be done, what might go wrong, what are the spare parts required, and so on and so forth. Sahu, next, please. And these all have been, put into DFS, which is an air traffic control infrastructure. We put in this infrastructure there, predictive intelligence, and we are trying to figure out, we are trying to ascertain that you are getting the right kind of, services from the this air traffic controller. Similarly, SBB is keeping their trains running constantly, regularly, without any fail in the Swiss country, because of this predictive maintenance piece being in place. So can we go next, please?
Yes. So I'd like to take your feedback. Yes. So you have seen the AI scenarios shared by Vipin Gandhi. So from the list of AI use cases, so if you could rank them from 1 to 4, depending on your initiative. Okay, I think we are on top of the hour. So let's move to how to start the Industry 4.0. Let me switch to the slide, Vipin.
Yeah, please.
Yeah.
Yeah.
If you could just take 1 minute and describe, I think it'll
Yeah.
be good.
Yeah. Yeah. So Sahu, we are seeing a previous slide. You'll probably need to scroll down to the next one, please.
Oh, yes, sure.
Yeah, thank you. So when you are talking about where do I start Industry 4.0 now, and a lot of people start wherever they are seeing the pain. And that is probably not the right place to start, because that pain might be a manifestation or a output coming out of a pain somewhere else. And when you start implementing these pieces of technology at the wrong location or at a wrong stage, what will happen is you will get stuck because you don't have enough data in the back end for you to be able to make successful predictions or make successful insights out of whatever you're seeing. So what we prescribe from SAP side is that you start at the core, which is the manufacturing piece. You start with predictive maintenance, product as a service, then you get into the asset intelligence network. Then you start moving outwards to say logistics will start coming in, move further outwards to get your vendors brought on Industry 4.0, and then you look at the customers. Normally, I have seen that people start worrying about the customers and vendors before they have internally done some homework and got the data in place. Most of the times people think that they have the right data, they have the right quantity of data, and they have sufficient data for them to be able to do a good machine learning algorithm or a good predictive kind of a implementation. Unfortunately, when you dig deeper, you find that that data probably is not enough, and that is where the system would start faltering. And this is also why we are saying start at the core and then move outwards from your organization. Sahu, given the time that we have, I think, okay. So what
Right.
is it that you are, okay, and I'll take another 30 seconds to finish this off. First of all, get a maturity assessment done. We can help you do that, or you can, just do a self-service online. Get a maturity assessment done as to where you are right now, and find out what are the opportunities available. Where is the business potential that will help you put all of these, realize certain, ROI, and then like I spoke earlier, do an assessment of where you are today, and if this is implemented, what is the impact that you're going to create. Think about what is going to happen in the future once you have already deployed these technologies based on the Industry 4.0 now principle or Industry 4.0 principles. Once you have done this assessment, then you start small. If you need to fail, you fail fast, and then start moving from one to the other piece. We usually recommend a design thinking, human-centered innovation workshop, which will sort of give you a very clear picture of where you are, where you need to go, what are the actions that you need to take. Right? There are if there are partners who are sort of working with you on these, we are happy to support you. We are happy to safeguard your investments, and we are happy to support the partner in getting you on this journey and moving forward. We also have services where we can do the implementation or do an enterprise architecture, or so that you have a very clear picture of how you're going to move forward and what is the right architecture to deploy. Yes, you have all of these information. I think Mukesh is going to share this deck with you. You will be able to access all of these. And if there are any other challenges that you are looking at, you want answers to, we can do those question answer session now, or we can connect later as well. Sahu, over to you.
Please, thank you so much for staying late, 5 minutes, and we're sorry to keep you wait for another 5 minutes. So what we can do is that we can take some questions. We will be here for another 10 minutes. Please let us know if you have got any questions. We will be happy to address any questions you may be having. So if there are questions with respect to customers, let's say examples. So I think this is the best site. Oops, sorry. Yeah, you can go here and can see what is customer stories. There are a lot of customer stories what you'll get once you go to this website. Okay, so if no more questions, thank you so much from all of us for staying late and attending the session and participating in the survey and asking the question. We'll be sharing the recording and the deck with all of you. And if there is any questions, like Mukesh, who works with you all the time, so you can either reach out to him, myself, or Vipin Gandhi. Anything last word from your side, Mukesh?
Thanks a lot to the entire SAP team, to Satya, to Vipin, to Marvin, to Gerald, for taking us through the entire session. And thanks everyone for joining and staying till the end of the session. At any point in time, you have any questions, please do reach out to me. I have uploaded all the previous 4 recordings already onto the Indus YouTube channel. I will be adding this to the channel as well. So you'll have one place, all the 5 sessions available if you want to share it with your colleagues and teams. If you want to do a one-on-one conversation with any of the experts that we've had so far in this entire series, please drop me an email. You can write to mukesh.gupta@sap.com, or you can write to admin@induscommunity.com, and I can connect you to the respective speakers. So with that, thank you so much for your time. And I hope that the series was useful, helpful, and helps you in your transformation journey as well. So thank you so much. Take care. Bye.
Yes, thank you. Bye.
Thank you. Thanks, everyone.